Okay, here are the solutions for the review exam for vectors. First problem, find the scalar product of the vectors 60, 25, and negative 30, 40. You should be pretty used to doing this on the quizzes by now, but basically the scalar product, what you do is you put a dot between the two, and then you're going to multiply the x terms together, so you get 60 times negative 30, and then you add it to the product of the other two terms, the y terms, 25 and 40. And so that'll give you negative 1800 plus 25 times 40. I think you can figure it out without the calculator, but if you do use the calculator, you get 1,000. So you get 1,000 minus negative 1,800, so that would be equal to negative 800. Okay, is the scalar product. Okay, let's go on to part B. Two markers are at the points 60, 25 and negative 30, 40. A surveyor stands at the origin 0, 0 and looks at the marker P. So let's kind of draw an approximate sketch of that. Let's say that that's about 60 and 25, so this would be point P. And then the second marker would be at point Q, would be at negative 30, 40. Q, negative 30, 40. Okay, and then we can draw position vectors going from the origin to each one of these points. And we'll pretend that there's a surveyor here. We'll draw her pink dot there. And she is looking at point P, and then she turns to look at point Q. So she makes an angle theta right there. And so basically what we're going to do is we're going to figure out what theta is by using these two vectors that we just drew. We drew vector OP, this is vector OP, and we drew vector OQ. And the x component and y component of OP and OQ are the exact same numbers as you find in the coordinates for P and for Q. You just write them vertically instead of horizontally. Okay, so now we have OP and OQ. And how do we find the angle between those two? Actually, remember, when you do the scalar product, you are actually finding out indirectly whether lines are perpendicular or parallel or at a certain angle. And if you look on the formula sheet, you'll find the formula there. But basically, the definition of the scalar product is that it's the magnitude of each of the two vectors multiplied times each other times the cosine of the angle in between the two. So if you want the angle between the two, then you could just divide both sides by the magnitude of V and W, and then you'll get something like this. Okay? So we just found the dot product up top. So we know the top is negative 800, right? So now all we need to do is find out what the magnitude of V and W are, and then we'll be able to, or in this case, OP and OQ are, and if we do that, then we'll be able to divide it out and find the cosine of theta. So let's see. Now remember how to find the magnitude of a vector? Basically, you take the vector, negative 30, 40, and you do Pythagorean theorem on it, okay? So the magnitude of OQ would be negative 30 squared, which is the same thing as 30 squared, because when you square a negative number, it becomes positive. And you add 40 squared, and you take the square root of that. So we'll do that. We'll take square root of 30 squared oops, yeah, okay, 40 plus 40 squared and that is equal to 50. Makes sense, right? 3, 4, 5 triangle. Remember the 3, 4, 5 triangle? Okay, so the length of OQ is 50. Okay, and what about the length of OP? It's equal to 60 squared plus 25 squared. So let's try that. 60 squared plus 25 squared gives me 65. Wow, these are nice even numbers. Well, it's a test, of course. Okay, so now we have the lengths of each one, which are here. Okay, so now we know that the v dot w is negative 800, which we got from part A, right? And then from part B, we now know that the denominator is going to have 50 and 65. Okay, and so now we can multiply that out. We'll put negative 800 divided by, and then we'll put a parentheses because we want to always put parentheses around the denominator. And we end up with negative 2.46. Negative 0.246. And then we're going to take the inverse cosine of each side. So we'll have theta equals the inverse cosine of negative 0.246. Inverse cosine of negative 2.46. And we get 104 degrees. And I'm just wondering if I am in degrees or not. Yes, I am in degrees. So that is 104 degrees. 140 degrees is an obtuse angle, bigger than 90 degrees, right? Makes sense. It kind of looks like one there, right? All right. So that was the answer for B, 104 degrees. All right. Moving on to number 2. The vertices of the triangle PQR are defined by the position vectors, and it gives us 3 position vectors right there. And it says to find PQ. And we can make PQ out of these vectors here. Let's see, PQ, using these vectors, if we had PO and OQ, then that would give us PQ, right? Because P to O, then O to Q is the same thing as P to Q. So, do we have PO? No, we don't, but we do have OP, so we could put negative OP plus OQ, which we do have, right? So we could just do OQ minus OP, actually. We'll do OQ minus OP. So we'll do that. So OQ is equal to 3, negative 1, 2. And OP is equal to 4, negative 3, 1. But I'm subtracting it now. So I'm going to get 3 minus 4 is negative 1. Negative 1 minus a negative 3 is negative 1 plus 3, which is 2. And 2 minus 1 is 1. So the first value I get is, for PQ, I get negative 1, 2, I'm going to copy it right here. I'm going to put negative 1, 2, and 1. And then PR is the same thing as PO plus OR. And so that's the same thing as OR minus OP. So let's do that. OR is 6, negative 1, 5. And OP is 4, negative 3, 1. So let's do that subtraction. So 6 minus 4 is 2. I'm just subtracting the x components. Now I'm going to subtract the y components. Negative 1 minus the negative 3 is negative 1 plus 3, which is 2. 5 minus 1 is 4. And so the answer is 2, 2, and 4. Okay. Now show that the cosine of RPQ is 1/2. RPQ. Okay. Now, the only kind of trigonometric thing that we did in this whole chapter is the the scalar product formula. So we know that basically the cosine of theta is equal to v dot w divided by the magnitude of v divided by the magnitude of w. We just need to figure out which vectors we're looking for here. And since the angle is RPQ, RPQ, the two vectors we're trying to find the angle between would be PR and PQ. So PR and PQ, do we have those? Yeah, we just found them right here. They led us straight to it. So first we need to find the scalar product of these two. So we're going to take 2, 2, 4, and we're going to take the scalar product of it and negative 1, 2, 1, and that'll give us the numerator. And so that is equal to negative 2 plus 4 plus 4. So we multiply the x components together, the y components together, the z components together, and then we add them all up, and that gives us 8 minus 2, which is 6. Okay, so the numerator turns out to be 6, and the denominator would be the length of each of these vectors. So the length of this vector we find using Pythagorean's theorem. 2 squared, an extension of Pythagorean's theorem in 3 dimensions, okay? So it's actually equal to 2 squared plus 2 squared plus 4 squared, which is equal to 4 plus 4 plus 16, 24, square root of 24, okay? And then what about this next one? This one is equal to the square root of 1 squared plus 2 squared plus 1 squared, so it's equal to 1 plus 4 plus 1, which is the square root of 6. Okay, so in the denominator here, I'm going to put the square root of 24 and the square root of 6. And you can actually multiply the insides of those roots, the square roots together, and we would get something like 154 or 144. And what do you know? Look at that. Of course, since it's a test, it's going to work out nice. The square root of 144 is 12, and there we go, 1/2. Okay, that's what we wanted to show the whole time, right? Okay, then it says find the sine of RPQ, which is the same angle we just found the cosine is 1/2. Now, to do that, I think the easiest way to do is draw a picture. And you say, well, I found the cosine is 1/2, which means that theta is actually 60 degrees. And you could do that with your calculator, too. You could take the inverse cosine of 1/2. It'll give you that theta is 60 degrees. Then you say, oh, well, what's the sine of 60 degrees? And you could do that with your calculator, too. Or you could just say, hey, it's square root of 3 over 2 from the unit circle. Hence, find the area of the triangle PQR, giving your answer in the form a times square root of 3. Well, it's a good thing we kept it in the form square root of 3 because that will make it easier to do this. Now, if you look on your formula sheet, remember that if you have a triangle, and like the one we drew right here, PQR or RPQ, and the angle, you know the angle, and you know 2 of the sides, then you can find the area of that triangle, PQR, by looking, if you look on the formula sheet, there'll be a formula there that looks something like this. So remember that each of the sides is square root of 6 and square root of 24. And the sine of theta we wrote down as square root of 3 over 2. And remember that square root of 6 times square root of 24 is equal to square root of 144, and the square root of 144 is 12. So we have 1/2 times 12 times square root of 3 divided by 2, and that is equal to 12 divided by 4, 3 times the square root of 3. So that's our answer, this, 3 times the square root of 3.